This is my lane detection algorithm for ENME489Y. Now, I just employed the standard pipeline that we worked on in class for the beginning of it, which is getting a snipped image, masking it, thresholding it, blurring it, edging it, and then determining the hue lines. Now, I had to change some of the initial values for some of these things in order to get a better overall image for the hue lines to calculate from. So first and foremost, I changed the size of the snipped image down to only detect the, or not to only capture the lanes on the road, as well as maybe a couple cars in front of it. So it also cuts out the sky, which was probably one of the biggest sources of random light that was not actually useful for determining the hue lines. And then also change the thresholding values of for the white lines to be detected, and it pretty much leaves, as you can see here, only the lane lines in the video detected. Almost everything else is removed. You can even kind of see the shadow of the car in front of it through these. I also decreased the blur a little bit because while having it blurred is obviously important because it makes it so there's less high frequency noise. Having it be too blurred resulted in edge lines that were a little too big. I then also changed the range of values for identifying the edges, which seems to have worked fairly well because this looks very similar to the other previous three images here, or not images, videos. I then just ran it through the hue line calculation that was given to us in the detection pipeline. Now, in order to separate these based on left and right lanes, I first looked at the theta value associated with an I index of the hue lines. So if if the theta attached to it was greater than 36 degrees but less than 90 degrees, it was determined to be a left line. And if it was greater than 90 degrees but less than 145 degrees, it was determined to be a right line. From there, I stored those values for the rho and theta in arrays that I initiated up here. I then took the median of those arrays and stored that in another array that stored all of the previous thetas and all of the previous rows. For the first 15 theta or the first 15 frames, I just immediately graphed the median as the line for the lane. So I'd say probably the first 30 to 45 frames are not the most accurate they could be because there's just not as much data to go with. And then after the 15th frame, on the 16th frame, I then instead took the average of all of the rows and all of the thetas of the previous 16 frames and used that as the new value for theta and rho that I graphed. Now, if there was no theta or rho given in any individual frame, because maybe the left lane wasn't detected for whatever reason, I just assumed the previous value for graphing purposes, but I did not add anything to either array. This worked pretty good because usually the lanes weren't changing too drastically, but as you can see in this lane right here, it makes this a little jumpy. In the first test video, it functions almost perfectly. At the very beginning, it's a little shaky, but becomes stable very quickly. The left line is a little jumpy, like I mentioned a little bit ago, but overall it's still fairly accurate. However, when it does go over the bridge, the right line becomes a little off, but it's only brief. In the second video, it functions alright. At the beginning, it's a little shaky because it's still getting those 15 frames, but it becomes stable fairly quickly. However, it's not as stable as the first video. And then when it changes lanes, it becomes fairly inaccurate for a brief moment. And then when it goes over the bridge, it becomes fairly inaccurate for a brief moment. I would even venture to say very inaccurate for a brief moment. However, that is not the only time it has issues. When it is going by the off-ramp, the right lane kind of veers off a little bit towards the lanes, the other lines closer to it. It's not a big difference, but it is not technically the most accurate line. And then also due to shadows, sometimes the left line becomes a little bit shaky or the right line becomes very randomly off, as you can see right there, due to the shadows of the cars and on the sides of the roads. In order to improve on this, I imagine employing another piece of code that determines how far off the new average is from the previous would help to mitigate some of the more extreme changes due to shadows and road pavement colors. However, I did not know how to do that. As for hardware, having a camera that is better at capturing the different light levels between the road and the lines on the road would help for handling situations like with the bridge being a paler color or the shadows dulling the lines color a little bit, making it harder for the algorithm to detect them.